We turn now to the asteroid being called a city killer. There's a chance it could hit Earth.
NASA has announced a concerning update. The chances of a newly discovered asteroid colliding with Earth have doubled, raising alarm among scientists and the public. This revised assessment comes after a series of critical observations, updated calculations, and fresh data that have reshaped predictions about the asteroid's trajectory. Asteroids have always been a potential threat. These massive space rocks, sometimes stretching hundreds or even thousands of meters, travel through space at incredible speeds. When their paths align with Earth's orbit, they pose a serious risk, keeping organizations like NASA vigilant at all times. However, up until recently, the asteroid in question had seemed to be just another object in space, potentially dangerous but not an immediate threat. But now, NASA has reported that the likelihood of it striking Earth has increased dramatically, and that has the global scientific community on high alert. So, what exactly happened to cause this sharp increase in the chances of a collision? How did astronomers come to this alarming conclusion? And what are the potential consequences if the asteroid does indeed make contact with Earth? Let's take a closer look at the situation, break down the science behind it, and explore the steps NASA is taking to monitor and mitigate this growing threat. The asteroid, named 2025 XG, was first identified several years ago. Initially detected by amateur astronomers participating in a global effort to track potentially hazardous space objects, it was originally thought to be just another ordinary asteroid within Earth's orbital vicinity. Early evaluations indicated minimal risk, with scientists believing it was unlikely to come close enough to raise concern. However, continued observations by NASA's telescopes provided a more accurate picture. As astronomers refined its trajectory, they discovered that while it wasn't on a direct collision course, it was gradually moving closer to Earth each year. Monitoring near-Earth objects and NEOs, like this one, is essential for assessing potential threats and understanding their long-term effects on our planet. NASA and other space agencies around the world have invested heavily in tracking these objects using advanced telescopes and space probes, with the goal of identifying any threats that could pose a danger to Earth. But despite years of monitoring, there were still many uncertainties about 2025 XG's trajectory. While early estimates suggested that it had a relatively low chance of striking Earth, astronomers couldn't be completely sure. These objects are difficult to predict, and their orbits can be influenced by a variety of factors: gravitational pulls from other planets, the sun's radiation, and even the slight pressure exerted by sunlight itself can alter an asteroid's path in unpredictable ways. The key challenge for scientists has always been the limited data available in the early stages of an asteroid's observation. The more time that passes, the more accurate the predictions become, and that's where the recent shift in predictions comes into play. How did we go from a seemingly low-risk scenario to a sudden doubling of the impact probability? The answer lies in updated data, advancements in technology, and refined calculations based on recent observations. Let's start by examining the role of gravitational interactions. As 2025 XG orbits the Sun, it is influenced by the gravitational pull of nearby planets, particularly Jupiter and Mars. Even slight gravitational nudges can subtly alter its trajectory, changes that may not be immediately apparent but can accumulate over time. Recently, astronomers observed that Mars' gravitational pull had slightly shifted 2025 XG's path. While initially minor, this deviation has significantly increased the asteroid's chances of colliding with Earth in the coming decades. As it continues its journey, additional gravitational interactions could lead to even greater shifts, further raising the probability of an Earth-crossing trajectory. Additionally, advancements in observational techniques have provided a more precise understanding of the asteroid's size and rotation. While early estimates suggested that 2025 XG was relatively small, possibly only a few hundred meters wide, new data indicates that it could be larger and denser than previously thought. Scientists have determined that the asteroid is denser than previously believed, altering the way they assess the impact energy of a potential collision. A larger and more massive asteroid would cause significantly greater destruction if it were to strike Earth. Another crucial factor in the revised projections is the advancement of orbital modeling technology. NASA and other space agencies have developed more sophisticated simulation tools that allow for far more accurate predictions of asteroid trajectories. These systems take into account various influences, such as gravitational forces, solar radiation, and the Yarkovsky effect, where an asteroid's rotation and heat absorption impact its path. With these improved modeling techniques, scientists have been able to refine their predictions of the asteroid's future movement. The latest calculations indicate that the likelihood of an Earth impact has risen significantly. Recent estimates suggest that the probability has climbed from below 1% to just over 2%, effectively doubling the previous risk. While 2% may seem like a low figure, in the realm of asteroid threats, it represents a significant concern. Even a slight increase in impact probability can have major implications for global preparedness and response strategies. Now that we understand the likelihood of a strike has doubled, let's examine why NASA is particularly concerned. The primary issue isn't just the immediate threat of an asteroid impact. While a 2% probability remains relatively low, it's still significant enough to warrant attention. The real concern lies in the long-term consequences and unpredictability of the situation. First, there's the potential threat to Earth. While the asteroid in question is relatively small on a cosmic scale, it is still large enough to cause significant destruction if it were to collide with our planet. The impact could unleash energy equivalent to several hundred megatons of TNT, far surpassing the power of any nuclear weapon ever detonated. Such an immense force could result in widespread devastation, especially if it struck a densely populated area. Depending on the impact site, the collision could trigger massive earthquakes, tsunamis, and fires. A direct hit on a major city could lead to tens of millions of casualties, while an ocean impact might generate a massive tsunami, causing widespread destruction along coastal regions. As the chances of a strike increase, NASA is intensifying its efforts to track and monitor the asteroid. The agency is utilizing a range of telescopes and radar systems to closely observe its trajectory and refine predictions as new data emerges. Scientists are also investigating innovative risk mitigation strategies, such as enhancing asteroid deflection techniques and formulating evacuation plans for potentially affected regions. Apart from NASA's efforts, international space agencies like the European Space Agency, ESA, and China Space Program are collaborating to track the asteroid. This global partnership plays a vital role in enabling a rapid and coordinated response should the risk of impact increase. Furthermore, NASA is enhancing its outreach initiatives to keep governments and international bodies informed about the potential threat. Public awareness campaigns, educational programs, and emergency preparedness strategies are all essential elements of a comprehensive plan to ensure humanity is ready to address any asteroid-related dangers. As the possibility of a collision with asteroid 2025 XG looms larger, the need for global cooperation has never been more urgent. The risk of an asteroid impact is a challenge no single nation or space agency can handle alone. Due to its potentially global consequences, mitigating this threat demands a coordinated international effort. NASA, the European Space Agency ESA, and other space organizations around the world are collaborating more than ever to address this pressing issue. A key aspect of these global efforts is the ongoing surveillance of 2025 XG. With uncertainties surrounding the asteroid trajectory, it is crucial for astronomers and space agencies to conduct more precise and intensive observations. By combining resources and leveraging some of the world's most advanced telescopes and space observatories, NASA and its international partners aim to track the asteroid with the highest level of accuracy possible. For instance, the European Space Agency has collaborated with NASA on multiple joint missions aimed at studying and tracking near-Earth objects and NEOs. This strategy utilizes multiple observatories to observe asteroids from different perspectives, providing the most accurate and current data. The more data collected, the better the chances of precisely forecasting an asteroid's trajectory. Additionally, these space agencies are working closely with governments and world leaders to establish frameworks for responding to a potential impact. While the risk of a catastrophic strike remains low, it's important to remember that the asteroid may become a more imminent threat in the coming years.